Hello everyone, this is Eddie the Magic Monk. In today's lesson we're going to talk about how to find or calculate pi using algebra and trigonometry. So the most simplest equation that involves pi, which everyone is familiar with, is this. The circumference of a circle equals pi times by the diameter, or C equals pi times D. Simple enough. So if I want to calculate pi, I can simply rearrange this equation, which will give me pi is equal to circumference divided by the diameter. Okay, so what that means is if you give me a perfectly measured circle, as in it is measured infinitely accurately, then you can simply put in the circumference of the circle, whatever it is, let's say it's 30, divided by, let's say it's 9.55 centimeters, as accurately as you can measure it. Then you can find out what pi is. But the problem is, nothing is that accurate. Okay, you can't have an instrument that is that accurate that will give you an exact number for pi. So therefore we need some sort of algebraic way of expressing what pi is, and therefore in order to do that we need to find some sort of algebraic way to express what C over D is. So how do we do that? Well, firstly, let me explain the theory to you using a diagram. So I'm going to start off by drawing a circle. So here's a circle, and let's say that we know for sure that the radius of the circle is 5 centimeters. So that means the diameter of the circle will be 10 centimeters, will be 5 plus 5, which is 10 centimeters. But there is no way for us to find out the circumference of the circle exactly unless we use pi, right? Because the circumference is equal to pi times the diameter. So we need pi in order to find the circumference. So that is no good for us. But what we're going to do now is we're going to draw another shape to approximate the circumference of the circle. So I'm going to start by drawing a square to try and approximate the circumference of the circle. So let's start by drawing a regular quadrilateral, a four-sided shape, and each corner of the four-sided shape is touching the circle. Now if you have a look at the perimeter of the square, it is not quite the same as the perimeter of the circle. The circle perimeter or circumference is going to be a bit longer than the circumference of the square. Okay, now let's try drawing a regular six-sided shape where all the corners are touching the circumference of the circle. Now you can see with a hexagon, a six-sided regular polygon, the circumference or the perimeter of the hexagon becomes a little bit closer to the perimeter of the circle, but still the perimeter of the circle is slightly longer. So let's now try an 8-sided regular polygon, an octagon. Okay, as you can see with an 8-sided polygon, an octagon, where all the corners are touching the circumference, the perimeter of the octagon becomes quite close to the perimeter of the circle, but still not the same. So let's try a polygon with 12 sides. Now with a 12-sided shape, a dodecagon, the perimeter of the dodecagon is becoming closer and closer to the perimeter of the circle. So let us write this down as a sentence. As n, the number of sides of the polygon, approaches infinity, the perimeter of the n-sided polygon, or shorthand n-gon, approaches the circumference of the circle. Right? If I draw a regular polygon where all corners are touching a circle that has 5,000 sides, for example, then it'll pretty much look exactly the same as the circle. So how does this information help us? Well, here's the good news. Even though we can't algebraically determine the circumference of the circle using the radius, we can algebraically determine the perimeter of the n-sided polygon using the radius. Right? So that means given the length of the radius, given this length here, I can tell you algebraically what the perimeter of the polygon is. So how do we do that? Well, let me show you now using this shape. Actually, let's go back to using an octagon. Okay, so with the octagon, what I'm going to do is I'm going to divide the octagon up into triangles. Now, ignore the vertical line and the horizontal line for the moment. So I'm going to divide it up into triangles by connecting a line from the center of the circle to each corner of the octagon. Okay, and you can see here what's happened is we have created exactly 8 triangles. Right? Ignore the vertical and the horizontal red line. We have created exactly 8 triangles, and each triangle, okay, we are going to now find the angle at the center of the circle, theta. So it's very easy to find theta because we know that a full rotation of the angle at the center of the circle, theta, would be, for the full rotation would be 360 degrees. 360 degrees is a whole rotation around the center of the circle. Now, 360 degrees is also equal to 2 pi radians. Actually, that's not going to help us because we don't know what pi is at the moment, so let's just forget that. Okay, at the center of the circle it's 360 degrees. So theta, it's going to be equal to 360 divided by n, because we have n number of triangles. Here n is equal to 8. Right now here n is equal to 8 because there are 8 triangles. It's an octagon, 8-sided shape. So theta will be 360 divided by 8, which will equal 45 degrees. Okay, so how does finding theta help us? Well, if you look at one of the triangles, I'm now going to focus on one of the triangles. So we're going to focus on this triangle here, this particular triangle. Right now, what I'm going to do is I'm going to divide this triangle into half using the red line. So here's where the red line comes in. Okay, so I've divided this triangle into half using the red line. And what happens is this triangle now forms a right angle triangle. Let me use a different color to highlight it. this triangle now forms a right angle triangle, right, where we have a right angle here. This angle is theta divided by 2, right, because if that's theta, then this is half of theta. So we can still find out what that is. And then we know what the hypotenuse of the right angle triangle is, because that is simply the radius of the circle. Right, the length of this side is the radius of the circle. Now, using simple trigonometry, we can find out what this side is. Let's call this side x. We can find out what x is using simple trigonometry because we have the length of one side and we have the angle. So once we find out what x is, so x is equal to, actually let's just start from the beginning. So sine bracket theta over 2 is equal to opposite over hypotenuse, so x over r. So we can express x as r times sine theta over 2 using simple trigonometry. If you're not sure about trigonometry, what the sine ratio is and all that, I suggest you have a look at trigonometry lesson 1 in my tutorials. You should be able to understand it pretty quickly. Okay, so now that I have found an expression for x, what is the perimeter of the circle? Alright, the perimeter of the circle, the perimeter of the n-gon is equal to x times by 2 to get the whole length of the base of the triangle, and then times by how many sides there are, so times by n. Okay, so substituting the expression for x into this equation, I will get the perimeter of n-gon is equal to r sine bracket theta over 2 times 2 times n. Okay, now we just want to get rid of all the unknowns. So what is theta over 2? Where does theta over 2 come from? Theta over 2, okay, so theta was equal to 360 divided by n. So let me substitute that in. So I have r sine, actually let's just leave that for a bit. So theta is equal to 360 over n, and then we divide it by 2 again, so that just moves the 2 down the bottom of the fraction, so it's just 360 over 2n. Okay, since 360 over n is equal to theta, I'm just substituting this into here, divided by 2, and then I have this 360 over 2n. Oops. Okay, so now let us continue from that. So if the perimeter of the n-gon is equal to this, right? Now, how do we find pi? Well, we're assuming that the n-gon is very close. The perimeter of the n-gon is very close to the perimeter of the circle. So in order to find pi, what happens is we're going to assume n is close to infinity. N is approaching infinity. So the perimeter of the n-gon, as n approaches infinity, now we're using the concept of limits. As n approaches infinity, the perimeter of the n-gon approaches the perimeter of circle. So if you're not familiar with the concept of limits, basically it just means that as x approaches something, what does y approach? Right? As n approaches infinity, the perimeter of the n-gon approaches the circumference of the circle. Okay, so we can assume that n is a very big number, and this is therefore the circumference of the circle. Now let's go back to our first equation. Pi is equal to circumference divided by the diameter. And we're going to substitute the perimeter of the n-gon to where the circumference of the circle is. So we get pi is equal to the limit as n approaches infinity of the perimeter of the n-gon. So r, let's rearrange that as well. So it's 2n r sine bracket 360 over 2n divided by the diameter, which is just 2 times the radius. And now if we simplify this equation, don't worry about the limit thing if you're uncomfortable with it. Basically it just means we're going to substitute a number for n that is very close to infinity, like 9 billion, 9.9 trillion zillion or something. Okay, so now we're going to cancel out the 2 on the top and the bottom, because 2 divided by 2 is 1 and r divided by r is 1. So pi is simply n sine 360 over 2n. Right, that is the algebraic way of expressing what pi is. Okay, so now let's find out what pi is using a calculator. So I'm in the Desmos graphics calculator, and the first thing I want to do is I want to change the graph settings to degrees, right? Because I'm using degrees right now, because I can't use radians because I don't know what pi is yet. Okay, so what I'm going to do is I'm going to set a number for n. Let's just start off with, let's say n is equal to 8, an octagon, like what we had. Now let's type in the equation n times sine bracket 360 over 2n. And it's given us a number 3.06, right? Not very close to pi. But if we make n a little bit bigger, let's make n equal to 1000, and you can see that pi is now very close to the exact number for pi. Okay, now I'm gonna go crazy and give n an extremely big number. Right, n is extremely big. Now have a look at this number for pi. 3.14159. Right, exactly what pi is. Okay, thanks for watching the tutorial, guys. Hope you found this useful. See you next.